Howdy, and welcome back to another segment of Barebow Basics. With indoor season already underway for many of you, it's time that we get this bow built. But with the amount of information I want to share, I'm going to stretch it out over multiple segments so that I can give each topic adequate detail. For this segment, we're going to start by covering the concepts of limb preload and setting your tiller. Then we'll move on to making lateral limb adjustments to ensure that our limbs are aligned. And then last, I want to delve into an often overlooked but very important concept of making sure that your bow is on plane. So let's get right to it. We'll start our discussion focusing on the limb bolt. Unlike traditional or wooden takedown risers, competitive ILF risers offer huge ranges of tuning capability. The limb bolts can be adjusted and set anywhere in their working range, whether they're turned all the way in or backed out 5 to 6 turns from fully in, depending upon manufacturer. Where you set your limb bolt will determine how much preload your limbs have. Preload is essentially how much tension your limb is under when the bow is assembled and strung at rest. Changes to preload effectively change the amount of draw weight off the fingers for the archer. And with the exception of some risers that have articulating limb pockets, most ILF risers offer about a 10% draw weight range adjustment just by using your limb bolts. So for our beginner-friendly 26-pound rated limbs, you'd have about 1.3 pounds up or down based on the rating. Adjusting the limb bolts is a relatively straightforward process. However, there's a few things beginners should always be aware of whenever they plan to make changes. First, limb bolts always have some kind of locking hardware. This prevents unintentional rotation. Sometimes it's a set screw that goes through the side of the riser, but more often than not, it's a locking screw on the back side of the limb bolt. Before making any adjustments, you must release the locking pressure from the hardware by unscrewing it. When the limb bolt can turn freely by hand, you know you've released the pressure. I always recommend when beginners are setting up their bow for the first time to turn the limb bolts all the way in so they're bottomed out. Then use the common practice of taking a Sharpie and marking the face of the limb bolt with an indicator line that points straight towards the center of the riser. This gives you a nice visual indication whenever you're making adjustments for partial or full rotations of the limb bolt. When making adjustments, it's always better to de-string the bow. You do not want the preload tension on the limbs forcing the face of the limb root against the back of the limb bolt. Otherwise, when you turn the limb bolt, it can cause scratches and gouges in the face of your limb root, which is disliked by many archers on the used market. If you decide to back your limb bolt out to its maximum range, using this indicator line I just drew, I'm going to count 5 turns. You have to watch out for the geometry of your limb root. When you insert it into the pocket and you press it against the riser, if the tip of the limb root does not touch the back side of the bolt, the geometry is not compatible. This position, when strung, will put too much strain on the limb root. To solve this, you must turn the limb bolt back in enough so that it touches. At that point, the limb tip is supported and removes some of the strain off the root. This may increase the draw weight higher than you desire. If this is the case, you'll need to get a different set of limbs that are slightly lower in draw weight rating. For my setup, I like to run my limb bolts pretty close to bottomed out. I prefer the feel of the riser and the limbs when it's in this position. So I'm going to turn it all the way in and then back it out 1 turn using my indicator line and lock it in place. I'll repeat for the other side and we can proceed. With the limb preload set, it's time for us to talk about tiller. Tiller is the comparison of preloads between the top and the bottom limb, and it's generally measured using a bow square on the imaginary line that comes 90 degrees off the bowstring and intersects where the limb and the riser meet. We measure the top distance, and then we measure the bottom distance, and we compare them. If the top distance is larger than the bottom, it's known as positive tiller, and it's because your top limb's preload is set a little bit softer. Conversely, if the top distance is smaller than the bottom, it's known as negative tiller, and it's because your top limb's preload is set a little more aggressive. There's a lot of conversation in the barebow community as to what the right tiller is, but I can tell you from experience that beginners can't tell the difference either way because their form is constantly evolving. So instead, I teach my students to just set their tiller to 0. That means the top distance and the bottom distance are equal. With good form, this still produces a very smooth shooting bow. But better yet, it removes all the complications of worrying about just how much negative or just how much positive you need to keep your bow at. You don't even need a bow square when things are equal, because 0 or equal is equal. You can take an arrow, put it into the joint, hold it at a 90-degree angle to the bowstring, and run your thumb up to it. You can then insert it into the joint of the other limb and check that. I do this at events all the time, and it's a quick and fast way to see if my equipment has changed. When you're making your initial adjustments, choose one limb bolt. Don't try to make adjustments on both if you can avoid it. You won't get confused that way. You have to remember that adjustments on one will affect the other limb as well, because they work in harmony. The easiest way to conceptualize how to make adjustments is to imagine a long screw that goes through the limb bolt into the bowstring. Tightening the screw will draw the bowstring towards the riser to shorten the distance, and backing the limb bolt off will allow the bowstring to wander away from the riser for longer distances. Typically, you don't need huge adjustments on the limb bolt. It's like a 1/16 of a turn or an 1/8 of a turn. So let's check the tiller on our setup. First, we have to measure the top distance of preload. The most common approach is to clip the bow square onto the bowstring, let it dangle, and measure where it intersects with the limb and riser connection. I dislike doing this though because some bow squares have sharp metal on the clip portion and can actually cut the fibers of your bowstring. Instead, I use what I call the sweep method. I place the bow square into the joint of the limb and riser connection, and I sweep the bow square back and forth while taking readings. Whatever is the shortest or smallest reading is going to be 90 degrees to the bowstring, and that gives me my reading. For this top limb, it looks like I have an 18.35 millimeter distance relative to the inside of my bow square. If I flip the bow over and measure the exact same way for the bottom limb, and I sweep the bow square back and forth, I come up with what looks to be 18.5 millimeters. So we have about a 1.5 millimeter difference. The bottom limb is slightly larger than the top limb, so it's slightly negative. I'm going to go ahead and make an adjustment on my top limb in order to slightly increase this distance by backing off the limb bolt ever so slightly. Okay, so we're back. I destrung the bow, made a quick adjustment on the top limb bolt, and then locked it back in place, restrung the bow, and then snapped the bowstring a few times with about a 4 or 5 inch draw. This helps settle the limbs into their pockets with their new adjustment setting. Taking a new reading, I was able to see when I sweep on the top limb, I end up with 18.45 millimeters for a reading. And then when I check the bottom limb, the preload looks like it's also 18.45 millimeters. So my tiller is now 0 because the bottom distance and the top distance are equal. And all it took was about 1/6 of a rotation of my limb bolt. With the preload and the tiller adjusted, we can be confident the limbs are putting their energy into the arrow in a balanced manner at release. But like the wheels of your car that need an alignment in order for the car to go straight, we need to be sure that the limbs are putting that energy into the arrow in the same vertical plane. If not, there can be unintended consequences, such as twisting or torquing of the riser at full draw, and at the very least will make tuning a challenging proposition down the road. When you go to do your alignment, it's important to have the right tool set. Using something like biter blocks or early human tuning forks will guarantee much better results than trying to use an arbitrary reference point on the back of the riser. Let me show you why. If we take this as the rear view of the riser, and we assume the limbs are installed, but at a canted angle, opposite each other, it is still possible for the string to appear aligned through your arbitrary reference point, such as a rear stabilizer bushing, from string tip to string tip. But clearly, because of the opposite cants, the limbs are actually not aligned. Instead, when we use a proper tool set, it'll be much more clear when we have a biter block or tuning fork at the root of each limb, because we'll have 4 points of reference. Each limb tip plus the center of your tool. And as the string travels down the center of the limb through the center of each tool, and then connects over the riser, you'll have 4 points of alignment, each limb tip and the center of each tool, helping to ensure that the limbs in the string are more aligned with the riser. Like the limb bolts, limb alignment hardware has locking mechanisms. They need to be removed before adjustments can be made. I always recommend de-stringing the bow when making adjustments. Otherwise, the tension of the limb against the edge of the riser can cause scratching or gouges on the backside of the limb root. To make adjustments, I always recommend using 2 Allen wrenches. Insert one into each adjustment screw. This allows you to retreat one while advancing the other and make small, controlled movements in the limb dovetail. Small movements are generally all that are needed because we're pivoting over a very long limb. So a small movement at the root of the limb will magnify into a larger movement at the limb tip. One last thing I want to share that I can't demonstrate with the SF because its design is immune, but on modern risers like this Gilo that use a pivoting dovetail pocket, it's important that beginners do not bear down and tighten the inner adjustment screws. If they do, they can compress the metal of the dovetail slot and tighten the tolerance to the point where the ILF fitting on the limb will have trouble fitting in the slot. This is evident when the limb becomes very difficult to insert or very difficult to remove from the limb pocket. Instead, use the approach that I've taught you using the retreat and advance method to very gently position the dovetail pocket. Once you reach the correct position, back both adjustment screws off and then use very gentle fingertip pressure to turn them in till they touch. No actual force should be used to tighten them. Then use the locking set screw to back up the adjustment set screw and tighten it in with moderate force. This should be enough to keep the inner adjustment screw from moving. Okay, I have the locking hardware removed from our demo bow, and I'm going to go ahead and install the early human tuning forks. They basically twist into position on the limb root. You want them as close to the riser as possible for the best reading. And hopefully the camera can see. So it looks like on the near limb, we're very aligned. But on the far limb, or the lower limb, the indicator is off to this side of the string. That means I need to swing the limb out that direction to get the string to move that way over the indicator marker. So let's go ahead and make that adjustment. Okay, that actually took 2 sets of adjustments. After I had made my lower limb adjustment that we had seen to bring the string over the indicator, I found that my top indicator was no longer in alignment. And that happens. So I ended up making a second adjustment on the top limb to bring it out a little bit this way. And now we have pretty good alignment. Our string falls over the top limb fork indicators and the bottom limb fork indicators. We're not going to put in our locking hardware just yet because we're going to move on to the next step. At this point, many archers would think the bow is ready to be shot. But the truth is there's a critical step we still need to take that most beginners don't know about and many intermediate archers skip over entirely. Putting your bow on plane is critical to getting the most balanced and smooth shooting setup possible. Let me explain. During alignment, we thought that our limbs and string were aligned with the riser, and our tools will indicate that they're very, very close. However, due to the three-dimensional nature of a bow, it is entirely possible for your limbs to be canted to one side or the other in unison and produce the optical illusion that your string is aligned to the tools if the bow is tipped slightly this way or tipped slightly that way. This happens because we can't specifically tell exactly where our eye is when we're looking down the string. So how do we detect it? We measure on plane using a bow square. We're going to measure the difference in vertical planes between the bowstring and limbs and the center of the riser. We do this because we put a lot of effort into ensuring that our pressure point in our grip is centered on the grip horizontally. It makes sense to ensure that the vertical plane that the energy the limbs transfer to the arrow is also on that same vertical plane. If not, you can get resultant bow torque during and throughout the shot. In order to check the bow plane, we need to remove the grip. I've already taken the hardware out, so let's slide the grip off. We want the bare metal as it gives us the most precise measurement possible. We'll take our bow square and we'll hold it on the metal where the grip goes, extending it up to the bowstring. Since we're taking the measurement on the near side of this riser, I'm going to take the measurement on the near side of the serving. This looks to be about 8 millimeters. We'll repeat on the other side, holding the bow square flush against the metal on the far side of the riser, bringing it up to the bowstring and taking our reading on the far side of the serving. This looks to be just a touch under 2 millimeters. With a 6 millimeter differential, that tells me that my limb and string vertical plane is not in alignment with the vertical plane of the center of the grip. It's actually too close to the shelf window and needs to come out about 3 millimeters, or half the difference. So let's go ahead and make that adjustment. Remember, we're moving the entire vertical plane of the limbs and the string, which means that we have to make equal turns on both limbs to bring them both in the same direction at the same time. In my case, I'm bringing them away from the riser window. I always think of it in terms of away from the riser window or towards the riser window. That way I don't get confused as I go from one limb pocket to the other. Okay, so that took 2 attempts for me as I actually overshot a little bit. I moved each limb pocket about a 1/4 turn away from the riser window shelf. and that actually brought me out just a little bit too far by about 1 millimeter. After making a second correction and moving them back in just a touch, less than a 1/16th of a rotation of the Allen wrenches, I was able to bring them into alignment such that the limb and string vertical plane is now centered over the grip's horizontal vertical plane. And I know this because when I take my measurement again, on this side of the riser to this side of the serving, it's just a shade under 5 millimeters. And if I do the exact same thing on the other side, for that far side of the riser and the far side of the serving, it is also just a shade under 5 millimeters. So the center of the string, which is aligned with my limbs, is now centered on the vertical center line of the grip metal. Well, there you have it. The bow is ready for its final build out. We've preloaded and tillered the limbs, set our alignment, and most important, made sure everything was on plane. Some final thoughts for you to consider as you learn to undertake this process. First, take your time. While some of this may seem daunting, I promise you with practice and experience, this all gets much easier. Experienced archers can typically do all of this setup in just a few hours. Next, be meticulous about your adjustments. You're literally setting up the foundation of your shooting platform. So take your time to make sure each adjustment is right where you want it. If you don't, you can potentially introduce errors that will magnify in your tuning and shooting down the road and become difficult to chase down. And last, don't ever be afraid to keep checking your tiller, your alignment, or your plane on a regular basis as you're building out the bow, or even beyond as a maintenance item when you're shooting. So those 3 aspects of your bow can tell you an awful lot about how your bow is behaving and responding to your shooting style. One final note, as you may have noticed, there's some winter wear available for the channel. So if you're interested, hop on over to the Printify web shop and you'll be able to see long sleeve shirts and hoodies that are now available, again, as always, with no profit to me, set just above cost. As always, thanks for watching, and I look forward to sharing more information with you in our next segment.